Hi folks, this is Math 2800, Quiz 19. Suppose V is an inner product space. I have three vectors, x1, x2, and x3. Suppose x1 is orthogonal to both x2 and x3. We're asked to show that W, which is x3 minus the projection of x3 onto x2, is orthogonal to both x1 and x2. Okay, so this is actually the fundamental idea behind the Gram-Schmidt process, which we'll be talking about very soon in class. So what is W? It's x3 minus the projection of x3 on the x2, which is x3 minus x3 inner product with x2 divided by x2 inner product with itself, x2. Now, in class, using properties of inner product, we showed that this is 0. Okay, so that satisfies this requirement. What I need to show is that this vector is orthogonal then to x1. So I need to show that W inner product, I'm sorry, not x3. W is, okay. Now we need to show that W inner product with x1 is equal to 0. So to make things less cluttered, I'm just going to look at W as x3 minus some scalar times x2, because that's really all we need here. So W inner product with x1 is x3 minus some multiple of x2 inner product with x1. Now, I use the linearity of the inner product to write this as x3 inner product with x1 minus alpha times x2 inner product with x1. And now I go back to my hypothesis. I'm assuming x1 is orthogonal to both x2 and x3. So that means x3 inner product with x1 is 0, and x2 inner product with x1 is 0. That's a whole bunch of nothing. Okay? So that'll do it for quiz 19.